number 8 is talking about a binomial distribution. The book gives you a clever acronym for remembering it. It's BINS. So it says, what kind of probability distribution does it have? It's binomial. But why is it binomial? It's binomial because it meets these 4 criteria, BINS. So B stands for binomial. That means we have a success and a failure. I'm not going to write all these out. I'll just kind of tell you. The I means each observation is independent. So every time I answer a question, it's independent. The number of observations is fixed. In this case, 40 observations. And the S stands for set probability of success. And I do. It's 1/5 each time. So that's why it's binomial, because each question's right or wrong. There's 40 independent questions that I have a 1/5 chance of guessing correctly every time. So question 2 says, what's your expected score? So how do I find the expected score of a binomial distribution? And you say, I don't have any idea. And so we look at the formula chart. And this part of the formula chart right here says if X has a binomial distribution. Perfect. Exactly what I'm interested in. And here it is right here. This part right here. If the mean of X equals NP. So the expected value is the mean of X, which is NP, which is 40 questions that I have a 1/5 chance of guessing correctly. Gives me an average or a score of an 8 on this test. Now, as a little extension to this problem, in the old days, they used to have what they called a correction factor for guessing. And basically, they took off 1/4 of a point for each problem you missed. So you got 1 point for each one you got right, and they subtracted a 1/4 of a point for each one that you answered incorrectly. Sort of a little punishment for guessing wrong. So if they graded you that way, what would your expected score be? Well, you would still be expected to get 8 questions right. So you got 8 points. How many questions do you think you'd get wrong? Well, the rest of them, 32, right? If you guessed on every one of them and you got 8 right, you got 32 wrong, and you're missing or subtracting a 1/4 of a point for each one of those. In that case, your expected score would be a 0. That's why it's called a correction or a guessing correction, because essentially it evens out all your chances of guessing to get points. They don't grade it that way anymore, but that's how it used to be. Now it says compute the variance and standard deviation of X. So I go back to the formula chart. NP1 minus P. That's the standard deviation. Without the square root, that would be the variance. So the variance of X is NP1 minus P, which is 40 times 1/5 times 4/5, which is 6.4. And then the standard deviation is just the square root of that, which is 2.5298. Now, question D says, what's the probability you get exactly 25 questions correct? What's the probability that the number correct is 25? This will help us remember how to do this on the calculator. So we said this is going to be a binomial problem. So I pull up my calculator. It's under distributions. So I go second distributions, and I go down to binom, and I'm reminded that there's a PDF and a CDF. Well, this one is for a particular value, 25. So this is the PDF. So I want the binom PDF. I've got 40 trials. Probability of success is 1/5, which you could write like 1/5, or you could write like 0.2. And I want to know what's the likelihood I get 25 right. If I was writing this down like I'm using a TI-83, it would be NPX. That's what it says right there. Enter, chick, chick, whir. Really small, 4.75 times 10 to the negative ninth. Really a small chance that you get exactly 25 questions right. Now the next one says, overall you believe you do really well. You don't study for the multiple choice questions because you think you do so well in the free response. So you think you only need to get 16 questions correct. What's the probability you answer at least 16 problems correctly? She wrote, oh my gosh, this could take all day. It could, because what I'm looking for is the probability that you get 16 or more questions correct, which is 16 plus 17 plus 18 plus 19. It could take all day unless you look at the complement, which is 1 minus the probability that it's less than 16, or 1 minus the probability it's less than or equal to 15. And so now this is where I use the binomial CDF function of NPX. I needed a equal sign in here. Whoops. One minus that. So on the calculator, it's distributions, binomial CDF, NPX, whir, 0.997. So it's 1 minus 0.997, which is 0.003. So there's a 0.003 chance that you will correctly guess 16 or more questions correctly. Point just being this: your method of studying probably shouldn't be guessing on the multiple choice.